live.
Good morning. My name is David Long. I'm the owner at Pro Mold and Die. We make plastic injection molds. We don't manufacture any parts. We manufacture the molds for making a lot of plastic parts. We're currently involved pretty heavy with the appliance industry, and we're making a number of parts for the appliance industry now, and some you may recognize. This is the spray arm for a dishwasher. So that's something you probably recognize, and later on we'll take a walk through the shop and you'll see the mold that makes this part. But the mold then looks just the opposite of this, so we can mold this part. But we've done a fair amount of automotive work at the same time. Here's a part that you may recognize. This is a cup holder, and this is in a Toyota. It's a cup holder between the two bucket seats. Again, that's something that you would recognize. Here's a part that you might not, but is very complex, and certainly one of the most time-consuming projects we've ever had. And this is a under the hood part for a water manifold, and I believe this is for Ford. But that was one of the more complex molds that we've ever made. Another part you might recognize in a dishwasher, I said we're working on a lot of the parts for the appliance industry, and we've done several of these. It's the basket for the silverware in a dishwasher, and we've done a number of these molds. And another one that you might not recognize, this is on the bottom. It's one of the feet that goes on the bottom of an appliance. Could be a dishwasher, could be a washer or a dryer. And this is the leg, and it sits one on each corner, and it's got 8 sides to it, so you can put a wrench on it and you can turn it to get the balance and get the level that you want. And this was interesting because it's plastic, but there's 2 different kinds of plastic. One is rubber for the bottom, and the other is a stronger plastic for the strength. And before we take a walk out in the shop, I've got something else that you may recognize. This is in Mercedes, and it's a defroster and goes down at the bottom of the windshield in order to be a defroster. And what makes this unique, the holes that are in here are not round like they are in so many of these. I said it was for Mercedes. Each one of those holes has got 6 sides to it, which makes it very time-consuming to manufacture and very expensive. But for Mercedes, they thought the round hole made too much noise. So with the design of each one of these holes being a little different, it's quieter. So, but with that being said, I'm going to, one more that's interesting, and this is in my appliance. I've got it at home. This we refer to as an auger, and it's in a washing machine, and as it's spinning, it drives the clothes down to the bottom, and down at the bottom there's an impeller. So it's very efficient. As this is turning, the clothes are floating to the top. This drives them down to the bottom where there's a 3-blade impeller that we can show you later. Very popular, and I've got one of those. Here's another one that's similar. That shows you the impeller down on the bottom. And then this is the auger that drives the clothes down to the bottom to get beat up by the impeller. So I tried to show you parts that you may recognize in your everyday life, something that you're somewhat familiar with, just to keep it interesting. But I've done headlights, taillights. I've got a Harley Davidson, and we made the taillight that's on my Harley Davidson, something that you would recognize. At least I do. So, but with that being said, why don't we take a walk out in the shop and show you what a mold looks like.
How many people do you have working here?
25. 21 or 22 during the day and a skeleton crew at night of 3 or 4. But we try to automate as much as we can, and the day shift has the responsibility of setting up some of the more complicated machines, and then the night shift has the responsibility of maintaining them and keeping them running all night. We can start over here because I've got a part of a mold on the floor that'll show you what the impeller and the auger mold looks like. When that mold is done, it's around 18 or 19,000 pounds. Relatively speaking, a car is 3,000. This mold weighs, when it's done and assembled, it makes the equivalent of about what 6 cars weigh. This is part of the mold for the agitator for the washer. It's 1/4 of it. It's made in quarters. This is probably about 2,000 pounds. And when it's all assembled, it's close to about 17 or 18,000 pounds, but this is just a small part of it. We have
How long does it take to make that?
this complete mold from start to finish is going to be about 15 or 16 weeks. So it'll be in the shop for 3 or 4 months. The design is something we can show you. That design was probably 125, maybe 150 hours just to make the design.
And that was one solid block.
This was when we started, yes. All of that is, we've cut out of there. All of that we've cut out of there. But like I said, the design process is probably about 3 weeks. And our mold designers that we have, we've got 3 of them, and they all come from out of the shop. And a lot of them have come through an apprentice program that I went through. I went through an apprentice program at the TMA. And most everybody in here has either gone through that program, got 1 or 2 that are in that program now. And they work on the shop floor for a number of years, and if they want to continue, they can move into the engineering phase of it. It's not for everybody, but for some people it works out really good, and I like the fact that they've had hands-on experience in the shop, and the fact that they've had that, they get a great deal of respect from the guys that are in the shop right now, because they know I'm talking to somebody on the engineering side who's done what I'm doing today. So that helps, carries a lot of weight. This process over here, we're cutting metal, we're removing metal with electricity. It's not like a drill or something. We're removing metal with a controlled short circuit. And we're removing metal. We actually take this shape, this I think you'll find interesting. We cut this in the mills, in the CNC mills. Now we have to put that detail into a piece of steel. We can't cut it because it's too thin. We can't cut it. So we make this electrode, And then we put the electrode in here. We put the electrode in here. And they're actually burning that in the steel. Hey, Mike. I'm going to ask the operator to raise that so you can see what we're doing. Mike, if you would just raise that, I want to show him the electrode. I showed you the electrode on the bench. I want to show you what it's doing. That's like the electrode that you saw on the bench. And what it's doing as he lowers the tank, he's putting that rib into the steel. Have you got a part? So the other side of the shop is the milling department. They would mill and machine that electrode. Once the electrodes are manufactured, they're brought over here along with the steel, and then we call it, it's burning. We burn that detail into the steel. And there's a spark gap between the electrode and the steel, and that spark is what removes the metal. These are the ribs that he's putting in. These are the ribs that he's machining into that steel. That's what it's going to look like in plastic. But much too small for us to cut. We'll take a walk over by the milling department. Oh, this is, I mentioned the spray arm. This is where the spray arm is being cut. I showed you the spray arm that's for the dishwasher. This is the spray arm being cut. And if we walk over here, this is where the electrodes are being cut. This is a finished one, and this detail, this is the detail that's going to be burned into the piece of steel. Walk over to the assembly area. Oh, here's an interesting cavity that we just cut, and we'll show you a part on the way out. This is a baffle that goes in a dryer, a clothes dryer, and it's for a front loader that's got a barrel, and then there's 4 baffles in it, and this is the cavity for the baffle. We'll see if we can find you a part on the way out. This is an assortment of parts. These are all parts that are going to be assembled on a job that make the spray arms. And this mold for the spray arms is going to make 4 at one time. It's going to make, and they get glued together, so you've got a set. You've got it. You're going to have 2 tops and 2 bottoms, and after these are molded, they get assembled, and they get actually get welded together. They melt the plastic, and they actually weld them together. Another assortment of the parts that are going to be assembled. Some other parts that we've done that are sitting around that are coming back for changes. Another automotive part that goes in between the seats. So, not all appliances. We've got some automotive as well. Here's one that's being milled. They're milling a baffle. And they're milling the outside of the block to a size that's going to fit into a pocket. And this is part of the baffle project. But you can see the automation once they set this up, which might take them a half hour to 45 minutes. It'll probably run maybe 5 or 6 hours on its own. You want to go back up front where we were, or the other conference room over here? Maybe in here. Yeah, go in here. You got a mold up on the screen. Can you open that, Colton? Show us any parts of that?
Sure. So this is the outside of the tool.
That's fully assembled. That's a picture of it fully assembled.
We can cut a section view through it so you can see the inside.
Colton spent about a year working on the shop, in the shop floor. Went back to school, got a degree in engineering, and now he's back here working in the engineering department.
So this actually makes this part right here. It makes 2 of them, one on the left and on the right.
Yeah, you can see the inside. You can see how many components and how much work is in there.
You don't think about it at first. You think, it's just going to open and close, but there's actually a lot of different moving components going on inside there.
The plastic comes through here and goes up through here, goes through a manifold, and then from that manifold it goes into the parts, through the gates and the runners and the gates. And it drops 2 parts, and I've seen it run a number of times, and it runs about 54 to 55 seconds. So you're dropping a part, so it's an easy 65 or 70 shots an hour.
How long does it take to design that?
A month?
Yeah.
Yeah, a month.
Something like that.
Yeah.
And you do it on the computer first, and then someone has to make it for real.
Yeah.
Yes. 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 And
it all
that's
starts with a part file from the customer. So they'll send a 3D model of the part that they want to build, and then we design everything around that part.
yeah, that's a good point. They send us a part that's 100% what they want. And then our responsibility has got nothing to do with the part. other than we review it for any design issues and make recommendations or suggestions to make a better mold, we call that a design for manufacturing meeting. And we have that with the customer, and we make suggestions that would make for a mold that runs faster, less maintenance, less money maybe. We point out a lot of things in the part, but then the customer has got the responsibility of the part, and we're done with that once we finish that meeting. And then we take that part, and we have the responsibility of designing the mold, where the plastic's going to come in, how it's going to come in,
How the part's going to come out.
how it's going to come out, how it's going to be cooled.
That's something interesting about this tool here. It uses a conformal cooled insert.
That's
So
brand new technology. Oh,
Yeah,
you got to
so-
show them that.
Yeah.
This is brand new technology within the last year or two.
Say it again, what is it?
They grow the steel.
3D printing.
We give them, you've heard of 3D printing on plastic. Of course, you can 3D print a part. Well, now they're 3D printing the steel. We give them the design of the steel component, and they 3D print it in steel. That part was grown. That's what we refer to it. It's grown with a laser and starts with a steel powder, and they use a laser to melt it, and they grew that part to within 40 thousandths of an inch or 1 millimeter of the finished dimension. We get it in here, and then we will finish it. But maybe Colton, you can show them the advantages with the
so
water.
The advantage of this, the reason we do it, is that traditionally we will just drill straight water lines into the part. We just have to go completely straight or maybe on an angle, but we can only just drill the lines where the water is going to go through. But in this case, we're able to 3D print these looping lines that follow the geometry of the part very closely, so it lets the part cool a lot faster, which means a faster cycle time and more parts for less money.
They're thinking that this, inside that mold where all of those ribs are, might take 6 or 7 seconds out of the cycle. I mean, that's a big deal.
That's a lot.
We've got one of these molds out. We're making the 5th mold. 4 of them are running right now 6 days a week. 4 of those molds. And we're making a 5th. The one out there is the 5th. And this is the first one that's going to have this in it. And they're thinking that's going to take maybe 6 or 7 seconds out of it. Very expensive. But if you're drilling a water line, drills can't turn corners. You go straight, you go up, back, forth, out. But as you can see here, these paths here are the water lines following the ribs. If you turn a part over and show them the ribs.
Yeah.
The plastic that forms these ribs is very hot. But with this insert that's in here, the water can go in here, go around there, go over here and around there, and it follows the part geometry all the way around. New technology. 3D printing in plastic has been there for a few years now, but 3D printing steel is still relatively new. There's probably not 3 or 4 places. If we go within 200 miles, maybe we could find 2 machines. I tell you what, why don't you grab Aaron?
Sure.
Yeah, grab Aaron, and then we'll interview both of them and ask them how they got involved in this and where they got started.
And we're going to be ending this particular broadcast right now, and we will encourage people to come back and see those interviews
Okay.
in the future.
Okay.
Thank
Stay
you.
tuned, everybody. Thank you.
All right, thanks for watching.